Today we started the introduction of mole conversions. And we did some questions that were converting between moles and particles. And we learned that Avogadro's number is a constant, and it's 6.02 times 10 to the 23rd particles, whatever that particle happens to be, and the equivalent is for 1 mole. That is Avogadro's number. We started learning how to do these conversions by doing a couple of examples between moles and particles and moles. I'd like to do the remaining ones on the sheet so you can get a better grasp. So let's do those remaining 3 examples. Question 4 says how many molecules, that should be a ring-ding-dinger, that this is a molecular compound, and the particle is a molecule, in 2.43 by 10 to the second, which you may in your head want to have visual, that's 243 moles of sucrose. Now sucrose is C12H22O11. That isn't actually necessary for the question to know the chemical formula, but it is necessary for me to feel like you've got a good grasp of chemistry. To do these questions, you need to know what you're converting to what. So go back and look at your table. You're starting at moles, and you're converting to particles. The particle in question is a molecule. We have to use Avogadro's number. It's a constant. That's all we need for this question. So you write down what you're given. 2.43 times 10 to the second. And that's moles of sucrose. And then you're going to convert that into particles by arranging Avogadro's number so that the units will cancel. On the bottom I want to put one I want to get rid of. So for every 1 mole of sucrose, it's the equivalent of 6.02 times 10 to the 23rd molecules of sucrose. I kind of ran out of room. So think about what will cancel, and then how do you do the math? Whatever you want. Okay, the answer to this question, when you plug it into your calculator, you're going to get on your calculator 1.4628 and so on 6 by 10 to the 26th. That's your units. Molecules is your final unit for that. Now, rounding wise, if you look back to your original question, there are 3 digits in your question. 2.43 has 3. You can only keep 3 in your answer. So your final answer when you round, represent it with a box, should be 1.46 times 10 to the 22nd. And you have to have the word molecules in there and the word sucrose, of which I ran out of room. But molecules and then sucrose. And a nice neat box around your answer. And that shows, and that's reasonable because you started off with 243 moles, at least 100 times more than normal. Your answer would also expect it to be large. Normally it's 23 for the exponent. 26 is reasonable. Example 2. How many moles are there in 8.02 by 1022nd molecules of oxygen? Don't forget that oxygen is O2, diatomic. And that's why the particle is a molecule and not an atom, even though it's an element. There are 2 atoms per molecule. Write down what you're given. 8.0 by 10 to the 22nd. The unit is molecules. Now the conversion factor on the table requires you to use Avogadro's number. So your decision will be where's the 1 mole going to go, on the top or the bottom. What you want to cancel goes in the bottom. What you want to cancel is Avogadro's number. 6.02 by 10 to the 23rd. And that's going to be molecules, that's a constant. On the top's 1 mole. We're talking about oxygen, of course. So mathematically on your calculator, you're going to plug it in. You're going to anticipate that it's slightly more than 1 mole, but not by much. No, I'm wrong. Less than a mole because its exponent is 22 and not 23. I'm pausing. The calculator answer is 0.13289, etc. You can only have 2 significant digits, so your final answer is going to be 0.13 moles of oxygen. And that question is complete. It's a one-stepper, and it's a conversion between molecules and moles using Avogadro's number. Last but not least, number 6. Number 6 asks you to convert how many particles, it says, are there in 3.455 moles of ferric acetate. What you need to know is what kind of compound this is. It is an ionic compound, so the particle should be a formula unit. And you get that off your yellow table or from your head, one or the other. Write down what you're given. 3.455 moles. Now, since you don't really need to know the molar mass of this compound, I'm just going to cheat and write down ferric acetate. Doesn't really matter what it is, because the law of Avogadro states that 1 mole of any substance, no matter what it is, always has 6.02 times 10 to the 23rd particles, and the particle for an ionic compound is a formula unit. So, mathematically speaking, the answer will be, the mathematical answer is going to be 2.07 times 10 to the 24th, 2.0799, 1. That's the calculator answer. Now my final answer can have 4 significant digits. So I'm going to look, that 9 is going to round that up. So 79 is going to become an 80. 2.080 times 10 to the 24th formula units of ferric acetate. And that is your final answer for number 6. Hope that helps. Good luck with your homework.